Jupiter is orbited by approximately 100 moons, but the most intriguing ones are known as the Galilean satellites. They were named after Galileo, who first observed Jupiter's satellites through a telescope in 1609. Astronomers around the world have been captivated by those moons ever since, seeking to uncover their composition and physical attributes. Numerous exciting discoveries have been made, including the presence of oceans, ice, volcanoes, and geysers on their surfaces. These findings have propelled the Galilean satellites to fame, and the recent detection of CO2 on Europa, one of the moons, by the James Webb Space Telescope, could have profound implications for the search for extraterrestrial life. Now, have you ever wondered how long it would take for a spacecraft to reach Jupiter and explore its moons? The answer depends on various factors, which you will discover in this video. Let's go. How long does it take to get to Jupiter? In the vast expanse of space, the journey to Jupiter is a feat that requires meticulous planning and innovative propulsion methods. Several missions have ventured forth, each employing distinct trajectories and propulsion techniques. Some missions, like NASA's Juno, opt for a direct route. These spacecraft, equipped with powerful engines, follow a straightforward path towards Jupiter. This trajectory is swift, taking around 13 to 14 months for arrival. It's akin to a sprinter dashing towards the finish line, relying on sheer speed to reach its destination. On the other hand, others like the Galileo spacecraft choose a more intricate path. They utilize the gravitational pull of planets such as Earth and Venus to gain momentum. This method extends the travel time, typically spanning 5 to 6 years. It's akin to a crafty hiker strategically using the terrain to cover a longer distance. A distinctive approach is the use of solar electric propulsion, exemplified by the Jupiter Icy Moons Explorer (JUICE) mission. This method harnesses the power of sunlight to generate thrust. While it's not as rapid as conventional engines, it provides sustained acceleration over time. JUICE, slated for a 7.6-year journey, exemplifies this patient and efficient approach. Comparing these propulsion methods reveals their unique characteristics. Conventional engines in direct trajectories produce rapid acceleration, akin to a sprinter's burst of speed, quick and powerful, but fuel-intensive. Gravitational assists, however, demonstrates the art of utilizing natural forces to gain speed. It's akin to a hiker wisely navigating the landscape. While it takes longer, it conserves precious fuel resources, making it a strategic choice for extended missions. Finally, the use of solar electric propulsion represents a sustainable, patient approach. It employs the gentle but continuous push of charged particles, akin to a steady marathon runner. While slower, it maximizes efficiency and minimizes fuel requirements. However, the planning of a mission depends strongly on what its objectives are. For instance, if you wanted to just insert the spacecraft in orbit around Jupiter, things would be quite easy. Even though getting to Jupiter has never been an easy task, today's agencies aim to get the most out of their missions. For instance, it would be really nice to observe both Jupiter and its moons together. Do you think this is impossible? Well, you're wrong. The idea of a grand tour of the Jupiter moons has been around for decades now. Imagine packing and leaving everything behind to explore a very distant country. Wouldn't it be really nice if you stopped from time to time along the way to maybe talk with the locals and learn about their culture, or maybe just to grab something to eat to let you move forward? Well, modern missions to Jupiter are trying to do something like that. Of course, the trip will last a bit longer than usual, but the amount of information and discovery that can be made by smartly planning this grand tour would be immense. This type of trip is what we really want to discuss in this video. We want to get at least an idea of how long such an unforgettable trip would last. JUICE is considered one of the most significant missions of this and the coming decades. Its primary objective is to explore Jupiter and its moons in unprecedented detail. By studying the gas giant and its various satellites, scientists hope to gain insights into the origin and evolution of our solar system, as well as the potential for habitable environments beyond Earth. The JUICE mission will revolutionize our understanding of Jupiter and its moons, unlocking countless scientific mysteries. It will provide valuable data on the moon's composition, geological features, and potential for hosting life. Additionally, JUICE will investigate Jupiter's magnetic field and its interaction with the surrounding environment. JUICE trajectory. first part. And it will do so by exploring the trajectory you can see on the screen right now. The animation shows the journey of the JUICE spacecraft to Jupiter. The proposed trajectory of JUICE is traced as a white line beginning inside Earth's orbit, shown in blue. By following the trajectory, it is possible to appreciate the gravity assist strategy, a sequence of flybys of Earth, Venus, Earth, Mars, and again Earth, that is used during the 88-month cruise phase of the mission. Yes, you heard it right, 88 months, which means our spacecraft will be wandering alone in interplanetary space for a total of more than 7 years. And that's only the time it will take to get to Jupiter. The fun will start later on, when JUICE will finally be all set to fly by the moons and finally perform an orbit insertion around Ganymede. You can see that as JUICE starts its first elliptical solar orbit, its distance to the Sun decreases. This results in an increase in speed, according to Kepler's second law of planetary motion, and the spacecraft overtakes Earth. During this first orbit, JUICE has maximum speed at perihelion, when it is closest to the Sun, but loses speed as it approaches aphelion. By the time the first solar orbit is complete, Earth is caught up with JUICE and the first gravity assist maneuver can be performed. At this point, the spacecraft is deflected towards Venus, whose orbit is shown in yellow, and it falls in the direction of the Sun, increasing speed. Crucially, each planetary flyby also causes orbital angular momentum to be transferred from the planet to the spacecraft. The acquisition of planetary angular momentum causes JUICE to further increase speed and is the key to the flight strategy. At launch, JUICE will not have sufficient fuel for direct transit to Jupiter, and therefore a series of planetary flybys is essential to allow the spacecraft to incrementally gain enough energy to reach its destination. After passing Venus, JUICE makes subsequent flybys of Earth, Mars, whose orbit is depicted in red, and Earth again before its rendezvous with Jupiter in October of 2029. The animation ends at the Jupiter orbit insertion point, so only the first set of gravity assist maneuvers that have been choreographed by ESA flight dynamics experts are shown. After this phase, JUICE will perform a total of 35 flybys of the moons. This will take some time, but how long exactly? I will soon unfold that for you. But before moving on, be sure to like or dislike the video so that we can improve it for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. JUICE trajectory. Second part. In July of 2031, when JUICE arrives in the Jovian system, its speed will be 5.7 kilometers per second. This speed is too high for the spacecraft to stay bounded to the system. Therefore, mission analysts plan to perform a first flyby of Ganymede at a distance of 400 kilometers to reduce the speed by 300 meters per second. Almost 7.5 hours later, the spacecraft will use its main propulsion to reduce speed by a further 900 meters per second, allowing it to enter an elliptical orbit with a period of 272 days around Jupiter. After the first orbit and still using Ganymede's gravitational assistance, the period will be reduced to 57 days and subsequently to 36 days using the same maneuver, thus making the orbit nearly circular around the planet. There are only 2 planned flybys of Europa during the mission. These will take place immediately after the first flyby of Callisto, initially planned for July of 2032. Now hear me out, because this is crazy. For the flyby of Europa to occur under the best light conditions, the speed resulting from the flyby of Callisto must be calibrated with a precision of a few meters per second. This is the degree of precision engineers at NASA can reach. The space probe will use Callisto's gravitational assistance to increase the inclination with respect to Jupiter's equatorial plane to a value of approximately 26 degrees, which will allow it to study the environment of the polar regions of the gas giant. 3 new flybys near Callisto will be used to return JUICE to an orbit around Jupiter, and then perform 10 subsequent flybys of Callisto. But here comes another problem. At this stage, JUICE's relative speed to Ganymede is about 3.8 kilometers per second, and this is too fast. If it had enough propellant, it could slow down to the desired speed, but unfortunately, the fuel is not enough. Thus, engineers plan to reduce it in succession using the gravitational assist of Ganymede, then of Callisto, and again of Callisto. Its relative speed at that point will have dropped to 1.6 kilometers per second. and a final gravitational assistance from Callisto will allow it to adjust the angle of the orbital plane around Ganymede with respect to the direction of the Sun. These maneuvers are spread over a period of 11 months, and this period will be used to study the plasma and magnetosphere present between the Jovian moons. The orbit intersection around Ganymede is a crucial part of the mission, as JUICE's primary goal is the in-depth study of Ganymede. In 2034, JUICE will become the first spacecraft to orbit a moon other than Earth's, and it will do so for a period of 3 months. End of mission and time estimation. Once the propellant has been consumed, JUICE will be deorbited and is expected to crash on the surface of Ganymede in September of 2035. As you can see, planning a mission to Jupiter and its moons is no walk in the park. Based on JUICE's Grand Tour plan, such a trip is estimated to take at least 10 years. Of course, after JUICE, our understanding of the solar system will have changed forever. That's all for this video. Thanks for watching. Do you think 10 years is a reasonable amount of time to visit Jupiter and its moons? Let us know in the comments below. We'll see you next time on the channel.